Hi, hello my dear students, a very good evening to all of you. Warm welcome to Turito live classes. So first of all, I can introduce myself. This is K. Kamlakar, your mathematics teacher, and I have an experience of 18 years in different competitive exams, and I made so many students as IIT rankers. So now we are in 9th standard. According to our 9th standard, we know the first chapter is real numbers. This is also known as number system. So we are going to discuss some concepts related to real numbers or number system. Okay. So this is our chapter name, number system. This is also known as real numbers. So here lesson objectives means what we are going to discuss in today's class. Introduction to numbers. How can we say one thing is a number? Natural numbers, whole numbers, integers, rational numbers. In our previous classes, we have learned something about the numbers. Among all those numbers, how can we say one number is a natural number or whole number or integer or rational number? After discussing them, we can discuss also the properties of numbers. Now, so first let us take the introduction of numbers. In previous classes, we learnt about various types of numbers. So already we have discussed what are the natural numbers, what are the positive integers, what are the negative integers, what are the rational numbers, what are the irrational numbers, like that. So just we can recap them to understand the concepts of real numbers perfectly. Okay, so in this chapter we are going to discuss more about the numbers. Okay, so first let us recap, so which we have learnt in our previous classes. So natural numbers. So we have so many numbers. Among all those numbers, how can we say one number is a natural number? The numbers which are countable are called natural numbers, and the set of natural numbers is denoted by capital N. So throughout mathematics, capital N means set of natural numbers. What is the meaning of natural numbers? The numbers which are countable. The numbers which are countable are known as natural numbers. If I ask you what is your age, you can say, sir, my age is 13 years or 14 years, like that. Here 13 or 14 is a countable number. If I ask you how many books are there in your school bag, you can say, sir, 10 books are there or 15 books are there, like that. So here 10 or 15 or 12, so these are known as countable number. That's why we can say they are natural numbers. So in the set form, we can write the set of natural numbers as n equal to 1, 2, 3, 4, 5, 6, so on. So by observing the set 1, 2, 3, so on, according to that we can say the least natural number is 1. So means the natural numbers begin with 1 only. There are infinitely many natural numbers, so we cannot count them. If I ask you how many natural numbers are there, simply you can say it is possible to say the number of natural numbers. So that's why we can say there are infinitely many natural numbers. Okay, so least natural number is 1, and if I ask you what is the greatest natural number, simply you can say that is we cannot count the natural numbers. So we cannot say which is the greatest natural number, but we can say which is the least natural number, that is 1. So now I can ask you some questions. You can send your answers in the chat box. So can you say whether 10 is a natural number or not? Similarly, you can say whether -5 is a natural number or not. If 2 by 3 is there, then can you say what about 2 by 3, whether that is a natural number or not? If I give you the number as 1000, so check whether it is a natural number or not. So you can send your answers in the chat box. I can check whether they are correct or not. Okay. Next, whole numbers. So just we have discussed what are the natural numbers. Now whole number means the collection of all natural numbers together with 0. is called the set of whole numbers and is denoted by W. So throughout this chapter or throughout mathematics, W can be taken as the set of whole numbers. So set of whole numbers means natural numbers including 0. So just we have discussed what are the natural numbers. The natural numbers means 1, 2, 3, 4, so on. So for those 1, 2, 3, 4, so on, if you include 0 like this, then you will get whole numbers, and the set of whole numbers can be represented by W. Here the least whole number is 0. So by observing this, the least number is 0 only. Every natural number is a whole number. Why? By observing these numbers, so we know 1, 2, 3, 4, 5, so on are natural numbers. So that's why we can say every natural number is a whole number. There are infinitely many whole numbers. If I ask you what is the least whole number, you can say that is 0. If I ask you what is the greatest whole number, simply you can say, sir, that is not possible because we cannot count the whole numbers. So we cannot say which is the greatest whole number. All whole numbers are not natural numbers because 0 is a whole number but not a natural number. So by observing this one, so all whole numbers are not natural numbers. Why? By observing the whole numbers, here we have 0, but 0 is not a natural number. But here we can say every natural number is a whole number. So regarding to this concept, I can give you some questions. Just you can send the message in the chat box. You can send your answers in the chat box. So if I ask you whether -1 is a whole number or not, what is your answer? So just you can send your answer in the chat box. If -1 is there, what can you say? Whether that is a whole number or not. If I ask you 15, check whether 15 is a whole number or not. Check whether 15 is a whole number or not. Yeah, I got some answers from 2 to 3 students. So excellent, very good. 15 is a whole number, but -1 is not a natural number because -1 doesn't lie in the set 0, 1, 2, 3, so on. Yeah, excellent, very good. Next, integers. How can we say one number is an integer? The collection of all natural numbers, comma 0 and negatives of natural numbers. What are the natural numbers? 1, 2, 3, so on. Negatives of natural numbers means by taking -1, -2, -3, so on. So these are the negatives of natural numbers. So just you can put the minus symbol before natural number, then we can say that is negative of natural number. The collection of all natural numbers 0 and negatives of natural numbers is called the set of integers and is denoted by Z or I. So you can represent the set of integers either by capital Z or capital I. So throughout mathematics, capital Z means set of integers or capital I means set of integers. So you can take the set like this. So Z equal to I equal to -3, -2, -1, 0, 1, 2, 3, so on. Here we have note. 0 is neither negative nor positive. On the real number line, we know all the numbers right side of 0 are positive numbers, left side of 0 are negative numbers, but 0 is neither positive nor negative. Just we can say 0 is a neutral number between the positive numbers and negative numbers. There are infinitely many integers. Here also we are not able to count the integers. So that's why we can say there are infinitely many integers. Every natural number is an integer. Why? 1, 2, 3, 4, so on. All these numbers are natural numbers and we can say they are integers. Every whole number is an integer. Why? So from 0, all these numbers, natural numbers including 0 are known as whole numbers. Then we can say every whole number is an integer. Okay, so that is the concept related to integers. If I ask you what is -14, can you say whether it is an integer or not. So send me your answers. I am waiting for your answer. Check whether minus 14 is an integer or not. If that is an integer, so what is that integer? Is it positive integer or negative integer? Next, I am going to give you next question. What about 1 by 2? What is your answer? Yeah, very good. Minus 14 is a negative integer. I got the answer. So from different people. Excellent. Very good. Next, if we take 1 by 2, 1 by 2 is not an integer because this is a fraction. So very good. So keep learning like this. Next, rational numbers. How can we say one number is a rational number? If p comma q are two integers and q not equal to 0, means in place of q you may take any number other than 0, then the expression of the form p by q is called a rational number and the set of rational numbers is denoted by capital Q. So throughout mathematics in general, capital Q can be taken as set of rational numbers. Here we have the example 1 by 4, 2 by 3, 7 by 5, 1003 by 2005. So these numbers can be taken as rational numbers because by observing 1 by 4, here clearly this is in the form of p by q. P equal to 1, q equal to 4. Similarly, the remaining numbers 2 by 3, 7 by 5, 1003 by 2005, these numbers are also in the form of p by q. Any number in the form of p by q. Any number in the form of p by q, when q is a non-zero number, is known as a rational number. The set of rational numbers is denoted by capital Q. Okay. So here I am giving you some questions related to rational numbers. So can you say what about 2 by 3? Check whether 2 by 3 is a rational number or not. So send your answers in the chat box. I am giving you 5 seconds only. What about 2 by 3? Check whether 2 by 3 is a rational number or not. Yeah, very good, excellent. So I got some messages. So 2 by 3 is clearly a rational number because this is in the form of p by q. Yes, excellent, excellent, very good. Next, here we have some points related to rational numbers. There are infinitely many rational numbers. Here also we are not able to count the rational number. That's why we can say there are infinitely many rational numbers. Number 2, there is no least or greatest rational number. According to the whole numbers and natural numbers, we can say which is the least number. But according to the rational numbers, we are not able to say which is the least real number, rational number, and which is the greatest rational number. 0 is a rational number. Here you may have doubt. So just you have explained us what is the meaning of rational number. Any number of the form p by q. If p comma q are integers and q is a non-zero number, then any number of the form p by q is a rational number. But by observing where 0 is not in the form of p by q, then how can we say 0 is a rational number? Very simple. So we can write 0 as 0 by 1 or 0 by 2 something. So in the fraction, whatever the denominator may be, if we have 0 in the numerator, then we can say that is a 0. The value of that expression is 0. So by observing 0 by 1, that is in the form of p by q, where p equal to 0 and q equal to 1. You may take p equal to 0, but don't take q equal to 0. Q must be a non-zero number. So 0 is a rational number. Number 4, every natural number is a rational number. Every natural number is a rational number. How can you say what are the natural numbers? 1, 2, 3, so on. Here by observing these natural numbers, every number can be written in the form of p by q like that. 1 can be written as 1 by 1, clearly that is in the form of p by q. 2 can be written as 2 by 1, that is also in the form of p by q. 3 can be written as 3 by 1. That is also in the form of P by Q. That's why we can say every natural number is a rational number. Okay. So, can you say what about 10? 10 is a rational number or not? What is your answer? So, can you send your answers? Yeah, already I got the answer. Very good. But 10 is a natural number, and we can say this natural number 10 is a rational number. Why 10 can be written as 10 by 1? But most of the students are sending the answers very quickly, ma. Excellent, ma. Very good. Next, every integer is a rational number. Here integer is nothing but that may be negative integer or positive integer or 0. If you take minus 3, this is negative integer, this can be written as minus 3 by 1, or you may write 3 by minus 1, both are same. Whether we have the sign either for numerator or denominator, then you can take the sign for the whole fraction. So, minus 3 is nothing but minus 3 by 1 or 3 by minus 1. By observing these two, both are in the form of P by Q only. P equal to minus 3, Q equal to 1, or P equal to 3, Q equal to minus 1. That's why we can say this is a rational number. So, what about minus 20? What is your answer? Can you say whether minus 20 is a rational number or not? What is your answer? I am giving you 5 seconds. Yeah, very good, ma. Very good. Excellent, ma. So, minus 20 is a rational number because this is in the form of minus 20 by 1 or 20 by minus 1. So, that's why we can say every integer is a rational number. Next. So, equivalent rational numbers. When two rational numbers are there, then how can we say those two rational numbers are equal or not? Two or more rational numbers which don't have a unique representation in the form of P by Q are called equivalent rational numbers. Example, if you take 1 by 2, if you take 1 by 2, so by multiplying 1 by 2 by 2, by multiplying the numerator and denominator by 2, 2 1 are 2, 2 2 are 4, we are getting this. If you multiply 1 by 2 by 3, by multiplying the numerator and denominator by 3, 3 1 are 3, 3 2 are 6, we are getting 3 by 6. By multiplying the numerator and denominator of 1 by 2 by 4, then we will get 4 1 are 4, 4 2 are 8. So, 5 1 are 5, 5 2 are 10. If you multiply by 100, 100 into 100 by 100 into 2, 200. So, by observing, if we take 1 by 2 equal to 2 by 4, by observing 1 by 2 equal to 2 by 4, by observing LHS and RHS, clearly we know the numerators are different numbers and the denominators are also different numbers. But we can say they are equivalent rational numbers. Why? By simplifying 2 by 4, again you will get 1 by 2 only. By multiplying the numerator and denominator of 1 by 2 by 2, we are getting 2 1 are 2, 2 2 are 4. That's why we can say these two are equivalent rational numbers. So, if you take 2 by 4 equal to 3 by 6, so can you say whether these are equivalent rational numbers or not? If you take 2 by 4 equal to 3 by 6, what is your answer? If you take 2 by 4 equal to 3 by 6, yeah, your answer is wrong. Once you can check your calculation. Yeah, now your answer is correct. Yes, very good. So, if you take 2 by 4 equal to 3 by 6, 2 1 are 2, 2 2 are 4, 1 by 2, 3 1 are 3, 3 2 are 6, we got LHS is 1 by 2, RHS is also 1 by 2. So, that's why we can say 2 by 4 and 3 by 6 are equivalent rational numbers. If I ask you, can you say whether 2 by 3 and 3 by 2 are equivalent rational numbers or not? What can you say about 2 by 3 and 3 by 2? Whether they are equivalent rational numbers or not? Yeah, very good, excellent, ma'am. Your answer is correct. So, 2 by 3 and 3 by 2 are rational numbers only, but they are not equivalent rational numbers. Why? Clearly we can say 2 by 3 is not equal to 3 by 2. 2 by 3 not equal to 3 by 2. If I ask you 100 by 1000, 100 by 1000 equal to 2 by. Here we have 100 by 1000 is LHS part, and if you take RHS as 2 by 100, can you say whether they are equivalent rational numbers or not? What is your answer? Oh no, that's wrong, ma. Yeah, once let us check. So you can cancel zeros, 2 zeros. We got 1 by 10 is LHS. Here 2 5s are 0, 1 by 50. Clearly we can say these two are not equal. That's why we can say they are not equivalent rational numbers. Next, simplest form of a rational number. When one rational number is given, then how can we express that rational number in the simplest form? If you suppose that p comma q are co-prime numbers, so already we know about the prime number, the number which has 1 and the number itself, so is known as a prime number, means only two factors exist for the given number. If you suppose that 3 is there, for 3, 1 and 3 are the factors, no other number is a factor of 3. If we take 4, 1 is a factor, 4 is a factor, 2 is also a factor. So here we have more than 2. If the given number has more than 2 factors, then we can say that is a composite number, that is not a prime number. If you suppose that p comma q are co-prime numbers and q not equal to 0, q not equal to 0 means q is a non-zero number, then p by q is called the simplest form. If we take 2 by 3, if we take 2 by 3, so we can say this is the simplest form. So for example, if we take 6 by 18, if I ask you what is the simplest form of 6 by 18, so clearly you can say 6 3 is 18, that equal to 1 by 3, that is 1 by 3. If we take 7 by 28, so if I ask you what is the simplest form of this rational number, simply you can say 7 4 is 28, you will get 1 by 4. So next, if we take 7 by 9, so simple, very simple. How can you say one number, one rational number is in simplest form or not? If the numerator and denominator has a common factor. If the numerator and denominator both have a common factor, then we can say that is a rational number, but not in the simplest form. If the numerator and denominator have no common factor, then we can say that is a rational number in the simplest form. So if I ask you what about 10 by 15, so can you say whether 10 by 15 is in simplest form or not? What is your answer? Yes, very good, ma. So 10 by 15 is a rational number, but that is not in the simplest form. Why? Where we can cancel 10 by 15 as 5 2 is 15, 5 3 is 5 2 is 10, 5 3 is 15, we got 2 by 3. 10 by 15, 10 and 15 have common factor 5, but if you take 2 by 3, 2 and 3 don't have a common factor. So 10 by 15 is a rational number. By converting that rational number into simplest form, you will get 2 by 3. So if you take 2 by 3, 1 by 4, 7 by 9, all these numbers are known as simplest form of the given rational number. If I ask you 10 by 25, what is the simplest form of this rational number? So what's your answer? 10 by 25 is given. So you can send your answers in the chat box. 10 by 25 is given. Yeah, very good. So 10 by 25, the simplest form of this rational number is 5 2 is 10, 5 5 is 25, 2 by 5. That's why we can say for 10 by 25, the simplest form is 2 by 5. Very good, excellent. So most of the students are sending the correct answers. That's great, very good. Next, here we can do some problems related to the concepts, so which we have discussed so far. Now look at this. Write 4 rational numbers equivalent to 4 by 7. So just we have discussed about the equivalent rational numbers. If you multiply the numerator and denominator by the same number, here you can choose the same number as your wish. Okay, but according to the problem, we have to write 4 rational numbers equivalent to 4 by 7. if you multiply the numerator and denominator by 2, 2 4 ja 8, 2 7 ja 14. So 8 by 14 is a rational number equivalent to 4 by 7. If you multiply by 3, 3 4 ja 12, 3 7 ja 21. This is also equivalent to 4 by 7. If you multiply by 4, 4 4 ja 16, 4 7 ja 28. So 16 by 28 is also a equivalent rational number to 4 by 7. If you multiply the numerator and denominator by 5, then you will get 5 4 ja 20, 5 7 ja 35. So actually 4 by 7 is the given rational number. Here to write the 4 equivalent rational numbers, I have multiplied both numerator and denominator by 2, 3, 4, 5. Sir, why are you multiplying by 2, 3, 4, 5? I want to multiply by 10, 11, 12, 30, your wish. You may take negative numbers also. It is not necessary to consider the positive numbers only. You may multiply, but remember you must multiply the numerator and denominator by the same number only. Okay, ma'am? Next. Irrational numbers. So just we have discussed what are the rational numbers. Irrational number means a number which cannot be expressed in the form of p by q, where p and q are integers and q is a non-zero number, is called an irrational number, and the set of irrational numbers is denoted by q dash. So q dash. So just we have discussed q is the set of rational numbers. Set of irrational numbers means q dash. Set of irrational numbers means q dash. A number which cannot be expressed in the form of p by q, where p comma q belongs to z and q not equal to 0 is called an irrational number, and the set of irrational numbers is denoted by q dash. So example 0.01, 001, 0001, so on. Here we are not able to express those numbers in the form of p by q. So for example, if we divide 2 by 3, if we divide 2 by 3, so actually 2 is less than 3, that's why you can take 0. Here you can take 0.3 6 18. Again you will get 20 minus 18 is 2, 20, 3 6 18. Again you will get 20, 3 6 18, so on. So there is no end. There is no end. So you are getting 0.6666, so on. There is no end. If we divide 1 by 2, if we divide 1 by 2, then what will you get to 1? So clearly 1 is less than 2. That's why you can take 0. Here 0.2 5 are 10, 0. 2 5 are 10, 0. So that's why we can say 1 by 2 is 1 is divided by 2, but here 2 is not divided by 3. 2 is not divided by 3. So that's why we can say 1 by 2 is a rational number and 2 by 3 is an irrational number. So because here by dividing the numerator by the denominator, we are not getting the remainder as 0. How can you say one number is an irrational number or not? When a fraction is given, if you divide the numerator by the denominator, if you divide the numerator by the denominator, after simplifying, if we get the remainder as 0, then we can say that is rational number. Otherwise, we can say that is an irrational number. Next, real numbers. Okay. So how can you say one number is a real number? A number whose square is non-negative is called a real number, and the set of real numbers is denoted by capital R. So real number system is the largest number system. In real numbers only we have integers, natural numbers, rational numbers or irrational numbers. Okay, number whose square is non-negative. Non-negative means 0 or positive. So for example, if you take minus 3, the square of minus 3 is 9. Clearly that is non-negative. If we take 0, 0 square equal to 0, that is neither negative nor positive. So by squaring one number, if we get a non-negative number, means if you are not getting the negative number, then we can say that number is a real number, and the set of real numbers is denoted by capital R. Next, here we have some points. All rational and irrational numbers are real numbers. So just we have discussed set of rational numbers is q. Set of irrational numbers is q dash. By writing all the numbers of q and q dash at one place, then you will get some numbers. Those numbers are known as real numbers. Next, every real number is either rational or irrational number. So, if for example, if we take 0, 0 is clearly a rational number because that can be written as 0 by 1 and we can say that is real number. If we take 2 by 3, so just I told you, by dividing the numerator 2 by the denominator 3, we are not getting the remainder as 0. So, that is why we can say 2 by 3 is an irrational number and that is also a real number. There exist infinitely many real numbers between two real numbers. So, for example, on the real number line, if we take 0, 1, 2, so on, minus 1, minus 2, so on. You may consider any two numbers. So, for example, if you take 0 to 1, between 0 and 1, there are infinitely many numbers. We are not able to count them. By observing 0 and 1, so between 0 and 1, 0.01, 0.001, 0.05, 0.999, so many numbers are there between 0 and 1. You may take any two numbers on the real number line, between them you will get so many real numbers. Next, decimal expansion of real numbers. So, decimal expansion means point, 0 point something or 1 point something like that. Every real number when expressed in decimal form is expressible either in terminating or non-terminating repeating decimal form. So, just I told you, by dividing 1 by 2 we are getting 0.5, that is terminating. If we divide the numerator 2 by the denominator 3, we are getting 0.666, so on. So, this is clearly non-terminating. Terminating means if we get the remainder as 0 by dividing the numerator by the denominator. Non-terminating means if we divide the numerator by the denominator, if you do not get the remainder as 0. Every real number when expressed in decimal form is expressible either in terminating or non-terminating repeating decimal form. So, if you suppose that the real number is p by q. So, how can you say one number is in terminating or non-terminating form? Just you can look at the given number p by q. So, if you express the denominator q as 2 power m into 5 power n for some non-negative integers m and n, then p by q is a terminating decimal. Okay. So, if you express the denominator q as 2 power m into 5 power 2 power m into 5 power n, then we can say p by q is a terminating decimal. If we are not able to express the denominator q in the form of 2 power m into 5 power n, then we can say p by q is non-terminating decimal. So, for example, if I ask you 1 by 2 is there, 1 by 2 is there, where if you take the denominator 2, this denominator 2 can be written in the form of 2 power m into 5 power n. 2 can be written as 2 into 1. 2 can be written as 2 into 1. We know if you multiply any number by 1, again you will get the same number. So, that is why if you express 2 as 2 into 1, where this 2 can be written as 2 power 1. If no power is there for the number, then we can consider that is 1, and this 1 can be written as 5 power 0. 2 into 1, 2 power 1 into 5 power 0, where by comparing with 2 power m into 5 power n, in place of m we have 1, in place of n we have 0. So, clearly the denominator is in the form of 2 power m into 5 power n. That is why we can say 1 by 2 is a terminating decimal. If you take 2 by 3, so can you say what about 2 by 3? Is it possible to express the denominator 3 in the form of 2 power m into 5 power n? Not possible. Why? Where the denominator is 3. If you observe 2 by 3, where the denominator is 3, but here we are not able to express 3 in the form of 2 power m into 5 power n. That is why we can say 2 by 3 is non-terminating decimal. So if you express the denominator in the form of 2 power m into 5 power n, then that is a terminating decimal. Otherwise, means if we are not able to express the denominator in the form of 2 power m into 5 power n, then we can say that is non-terminating decimal. So if I ask you, what about 3 by 100? What is your answer? So whether that is a terminating decimal or not. I am giving you 5 seconds time, 5 to 10 seconds. Yeah, I got some answers. Let us check whether they are correct or not. If you take the denominator 100, so here if you take 100 by taking the LCM, 2 5s are 10, 0, 2 25 times and 5 5 times. So now take the denominator 100. Now according to this, 2 into 2, 2 square, 5 into 5, 5 square. So by observing RHS, 2 square into 5 square, clearly that is in the form of 2 power m into 5 power n. 2 power m into 5 power n, where m equal to 2 and n equal to 2. That's why we can say 3 by 100 is a terminating decimal. So if I give you 4 by 12, what is your answer? Well, check whether 4 by 12 is terminating decimal or non-terminating decimal. What is your answer, ma'am? Yeah, I got some answers from different children. So let us check. If we take 12, 12 can be written as 2 6 are 12, 2 3 are 6, means this 12 can be written as 2 square into 3. 3 means 3 power 1. So we are not able to express in the form of 2 power m into 5 power n. In place of 2 power m, we have 2 square, no problem. But in place of 5 power n, we have 3 power 1. That's why we can say 4 by 12 is not a terminating decimal, means non-terminating decimal. So we can express this as 1 by 3. So hope you understood the concept so far which we have discussed. Now let us take some problems related to these expressions. Now show that 17 by 625 is a terminating decimal and express it in decimal form. Okay. So first of all, we have to show 17 by 625 is a terminating decimal. What is the denominator? 625. What is the denominator? 625. So take 625. Take 625. So by taking 5, so 5 1 ja 5, 12, 5 2 ja 10, 5 5 ja 25. Again by taking 5, 5 2 ja 10, 5 5 ja 25. Again by taking 5, 5 into 5, 25. Now the denominator 625 can be written as 5 into 5 into 5 into 5, 5 power 4. So here you may have asked, sir, but that is not in the form of 2 power m into 5 power n, where 625 can be written as 1 into 625, 17 by 625. So 17 by, so 625 can be written as 1 into 625. So if you multiply any number by 1, again you will get that number only. So 17 by 1 into 625. Again this 1 can be written as 2 power 0, whatever the base may be if we have the power 0, so except 0. So you may take the base as any number other than 0, and if the power is 0, then we can say that is 1. So according to that, where 1 can be written as 2 power 0 and 625 can be written as 5 into 5 into 5 into 5, 4 5s are there, we can write that is 5 power 4, 17 by 2 power 0 into 5 power 4. So by observing the denominator, clearly that is in the form of 2 power m into 5 power n. So the denominator is in the form of 2 power m into 5 power n. In place of m, what we have? 0. In place of n, what we have? 4. So that's why we can say, since the denominator is in the form of 2 power m into 5 power n, then we can say 17 by 625 is a terminating decimal. and express it in decimal form. So 17 by 625 is given. We have to express that in decimal form. Already in 8th standard we have discussed about the decimal numbers, 0 point something or 1 point something. For example, 1 by 2 is there. So 1 by 2 is there. By expressing 1 by 2 is a fraction, by writing it as decimal number you will get 0.5. 0.5. If we have 1 by 10, we can write that is 0.1. So these numbers are known as decimal numbers. So just like that we have to express 17 by 625 in decimal form. So here by dividing the numerator by the denominator, 17, the denominator is 625. But we know 17 is less than 625. So that's why you can take 0. Here you can take 1 point. Still 170 is less than 625. So you can take 0. Here you can take 0. Now 1700 is clearly greater than 625. So if you take 625 into 3, 3 6 is 18, that is more than 1700. So that's why you can take 2 times. 2 5 is 10, 2 2 is 4 plus 1 5, 2 6 is 12. So 0, 10 minus 5 5, 16 minus 12 4, 450. 450. Again 450 is less than 625. So that's why you can take 0. You can take 0. So if you take 4, 4 6 is 24. If you take 8, 8 5 is 40. 8 2 is 16 plus 4, 20. 8 6 is 48 plus 2, 50. So 8 6 is 48, but that is more than 4500. If we take 7 times, 7 5 is 35. 7 2 is 14 plus 3, 17. 7 6 is 42 plus 1, 43. 4375, clearly that is less than 4500. By taking 7, 7 5 is 35. 7 2 is 14 plus 3, 17. 7 6 is 42 plus 1, 43. So 10 minus 5, 5. 9 minus 7, 2. 9 minus 7, 2. So 44 minus 43, that is 1. So 125. 125. Still 125 is less than 625. That's why you can take 0. So by we know 625 into 2 is 1250. So we got the remainder as 0. So that's why we can express 17 by 625 in decimal form as 0.0272. So this is the decimal form of the number 17 by 625. So when we have the number in the form of p by q, to check whether that is a terminating decimal or non-terminating decimal, look at the denominator. Check whether we are able to express the denominator in the form of 2 power m into 5 power n or not. If you are able to express in that form, we can say that is a terminating decimal. Otherwise we can say that is not a terminating decimal, means non-terminating decimal. Okay. So these are some problems related to the concept which we have discussed. So remember, every day we are providing 5 questions. These 5 questions are known as DPP, daily practice papers. After completing the class every day, you can try to solve those questions. Or next day, in the first 5 or 10 minutes, I can explain those questions. Okay, thank you all my dear students for subscribing to Turito live classes. Thank you all. Thank you very much. Have a nice day.